So my talk today will not be focused on like breakthrough innovations, but rather I want to take a step back and look through where we need to work more as a community of practice and scientists. So for those of you who don't know, the CSA profiles are kind of like brief insights over the, can I have the, yeah. over the agriculture context, climate smartness of agricultural technologies, and policy and institutional environment. So it's been 5 years since this work has been ongoing. It's covered about 20% of the countries in the world. There's more to go. And the first profiles were developed in 2014 as an initiative between CIAT, CCAF, SCATIA, and the World Bank. It's been mobilizing a lot of human, technical, and financial resources, and it's become a big thing. So I want to follow up on what Andrew Campbell said yesterday, that we are like pretty much in a comfort zone, and I want to tell you why. So first, it's about the knowledge and expertise we have around CSA, or we know there is around CSA. And this figure shows that the production systems that have been mostly prioritized by stakeholders in the countries we've worked pretty much relate to grain crops, cash crops, and livestock. And there's like very little focus on roots and tubers, aquaculture, and mixed systems. The second graph shows you basically what the majority of practices selected by experts are focusing on. We're talking a lot about agronomy and livestock, and less about energy and post-harvest. The second like area of our comfort zone is the financial resources. So basically what our findings show is that most of our funding sources come from multilateral and bilateral institutions, and less so from government, private sector, and blended funds. So this kind of shows us that we need to diversify the financial mechanisms, but we also need to do a better job at understanding like how different funds are reported, because many times they don't come with a CSA tag, so they may be like the contributions may be underreported. And the last lesson learned is about adoption barriers, and contrary to let's say like common wisdom, which is focusing on economic and financial barriers, we found that most of the times experts were assessing that most of the barriers are around training and information, and then on policy and institutions. So this is probably because most of the practices and technologies that are or that have been included in these assessments were knowledge intensive or relying on inadequate extension service support, but maybe also because the research efforts that have been ongoing have focused on solutions to lift some of these economic and financial barriers, and less so on reducing the transaction costs through better policies, better trainings, and better information. So I'll conclude by saying that the challenges our food system faces will require us to push us out from the different comfort zones we're having, and kind of start thinking about forgotten and less intuitive production systems that contribute to food security and nutrition and livelihoods, that really look at practices beyond the farm, that look at the entire value chain, and that to diversify our understanding of like what can enable CSA adoption and scale out. So yeah, I'm done.
So there are a few people thinking about this in a big way, and it's running under the name Green New Deal. You see on the left side here, for example, the 5 elements of U.S. Congress resolution that doesn't have any binding legality, but it shows us that there is big thinking out there. So there should be net zero greenhouse gas emissions, maybe in 2030, sustainable infrastructure to support this, but also jobs and prosperity to actually which actually happen when you do this huge reconstruction in society that also should guarantee future access of people to natural resources. And all this should happen with justice and equity, so fair and just transitions. And on the right side, you see a few elements of this spelled out from a book of Jeremy Rifkin just now launched in May this year, and I think he's launching a new book, The Global New Deal, just now in October. So there will be an interesting debate coming up. But what you see here is again carbon tax in, fossil fuel out, a lot of emphasis on power supply, transport, and logistics, the Internet of Things, and stuff like that. And you see very little on actually agriculture, what they call carbon farming to bring carbon back into the soils and into ecosystems, and on restoration. And I think that's where we should be the ones bringing these elements into this discussion. And there's a lot more like green finance, regulation, and so on, where we can have contributions. And we need to look into this in the context of what is called the donut economics, the planetary boundaries on the one side, and what is needed for people to survive decently on this planet. And we look at, in particularly this is moving too fast. We're looking at what is now called superwood. New technologies starting from wood that take us into a totally different dimension of wood buildings, hardening, stabilizing, impermeabilizing wood, adding transparency, adding new qualities, and that's really, really interesting, and I think this is really exciting technological stuff that could bring a whole new range of applications to this natural resource. Did you know that, now it's not moving. Did you know that you can actually cool surfaces by having specific materials that reflect in a specific bandwidth that is going directly out to the space and not being absorbed by the atmosphere? And this is a new technology that is just starting and now also being able to be applied to wood. So you could see that this might become a huge solution for tropical cooling problems, for example, buildings and so on. This has been tested this is from the University of Maryland, it's a science article that has been tested in 16 cities in the US, giving up to 50% of cost reduction in cooling. So that's really, really interesting. And so this kind of stuff we are looking at, and yeah, time's up. Every person on the planet is using, on average, half a cubic meter of wood. And this generates a lot of questions about future trends. Is it going to grow exponentially? Is it going to grow just linearly? What are the society demands? And then a lot of decisions that need to be made on how to integrate this approach into value chains with food production. So food and non-production should be integrated. What should we have more bio energy or not, and all these kind of questions. And this is something we want to address. And these are, I'm a bit confused because there's always a different slide here than here. So these are the ideas we're trying to put together in a new proposal, which is going to look at those technologies, which is going to look at those at the question how to integrate it in value chains in a way that looks at value chains more in the shape of value webs actually, and then that's trying to answer these big philosophical questions about where we should go with natural products, where we should source natural products, and how we make this all happen for this planet so that we can actually have the donut and eat it. Thank you very much.
Thank you. I'm going to talk to you today about what I see as the role of science and scientists in developing climate-smart agriculture investment plans, drawing on some experience that we've had recently working on my team at CIAT, working with partners at the World Agroforestry, at CCAS's West Africa team, and under the leadership of the World Bank, also working under the umbrella of the Adaptation of African Agriculture Initiative, or the AAA initiative. I think we all know that there's a real demand and need for investment in climate-smart agriculture, and really this is what this AAA initiative is doing, trying to catalyze investment in CSA in Africa. Many others are also working on this. We heard here from Rabobank, a $2 billion initiative that they have in the private sector. Mirova Fund, responsibility as impact investors that really have an interest and need in this kind of investment. And we also just saw in the last month that the Global Commission on Adaptation released a new report that's calling for a year of action for adaptation globally around 3 revolutions that they're proposing around understanding, planning, and financing adaptation. And so I want to now turn to some of the work that we've been doing, share with you how we've been developing climate-smart agriculture investment plans, dive into them a bit in 2 countries, in Mali and Cote d'Ivoire, where we finished these and have identified 24 investments, 12 in each country, and first show you a bit about what's inside of those investments and some of the lessons that we've learned, that there's actually quite a bit of similarities among these investments and what's in them, and then I'll turn to the role that I see of us as scientists in this process. So when we look across these 24 investments in the 2 plans, we saw that across every single investment, extension had some component in those investments, 100% of the investments. And I think we know that this is important from the science and research that we've done, that farmers need to know what they need to do, how they need to change, and need the support from extension. This could be from the public sector, this could be from the private sector, traditional means or new innovative ICTs, but it's important. Second, infrastructure was in 88% of the investments, identified as a key part of what needs to be done. And this could be, again, from the public sector, investing in infrastructure to enable the other investments to be happening, or it could be from the private sector seeing some business opportunities to invest in, say, some sort of storage facility or other kinds of investments that they may make in infrastructure. Third, finance was very important. And this is something where I think we know farmers need the capital to be able to invest, and this was in 58% of the investments. And then certainly farmer networks, gender, youth, and enabling policies were also in many of the investments we saw as being an important part of that investment. So what have we learned about how science and scientists ourselves can best inform and be part of this process of climate-smart agriculture investment planning? And so I want to leave you with 3 take-home messages that I think are important here. First, the process is as important as the final product. We can't go and develop a CSA investment plan in our research offices and go drop it on somebody's desk and expect that this is going to be taken up. These people who are going to be using it in the end have to be part of the whole process. If it's a government-focused investment plan, make sure the government is there. We were there in this case in the ministry offices in Mali, in Cote d'Ivoire, making sure that they were part of the process and really leading it in the workshops and the engagements that we have. Ultimately, they're the ones that own it in the end. The process can go fast sometimes, and we as scientists have to move fast. It can also slow down. We can't get ahead of the process, and we have to respect that. Second, curated scientific information is needed, and it's often needed rapidly. We can't do a research project of a year, 3 years, 5 years. We found, had to have information almost instantaneously, if not, say, within a month. And I want to highlight, yesterday, Todd Rosenstock and his team launched a new product from a lot of effort that was put in to the Evidence for Resilient Agriculture era, which you can go on a website now and query different questions about what practices work where and get quantitative information out of that, which then we actually use in these investment plans as inputs into modeling as well as put directly into the CSA investment plans themselves. And then finally, we have to package relevant information, not any information that we think as scientists is important, but information that's going to be relevant to the investors who would ultimately use this, and then write for the audience. These are not scientific documents. These are investment plans. And as much as I think we as scientists feel like we can write very well, we found it was important to look outside, bring in people who can write for investors, write for the right audience, and that we can make sure that these are written in the way that speak to and can be ultimately used by the people that we want to be putting the investments into this. And so I think these are some take-home messages I see that if we all take to heart, I think as scientists we can be part of helping to identify the investments and ultimately helping to bring the finance in for the investments that are needed to provide the climate-smart agricultural transformation that's needed in this world. Thank you.
I'll focus on the uptake and impact of CSA on food security incomes and assets as indicators of livelihood outcomes, but also as indicators of resilience, based on a case study from East Africa. So in terms of the production systems in East Africa, they are mainly rain-fed and also dominated by smallholder farmers, making them highly vulnerable to climate change and variability. So over the last few years, we've seen a lot of climate-related risks affecting many farmers in the region in terms of variable rainfall patterns, frequent drought events, floods, and also prolonged dry seasons. So in order to help these communities adapt to climate change and also manage the risks, CCAFS has been working with a number of partners to evaluate a portfolio of technologies that focuses on crop, livestock, and soil and water management. So in order to assess their impact and also uptake, based on the work we've been doing in the last 7 years, since 2011, we used a quasi-experimental approach that combines statistical matching and econometric modeling in order to provide reliable estimates of impact. So what are some of the emerging trends in terms of uptake? From the two figures, you can clearly see that there's an increase in uptake of the technologies, especially those related to livestock and also improved crop varieties, and also combining this with improved management practices, both for the crops and also for the livestock technologies. And what are the key drivers of adoption? We find that adoption is influenced both by household level factors and also institutional factors. And this included social capital in terms of membership in different groups and the community-based organizations. We also had wealth status, access to climate information and services, access to credit, access to financial services, and also other cultural factors. So all of these are actually associated with the higher likelihood of adoption. Now, turning to the impacts, what are the key emerging results? So in terms of the impacts, we find that for the crop-related technologies, they had positive and also significant impacts on all the livelihood outcomes, whereby, for example, the crop technologies increased household dietary diversity score by about a factor of 2, and also increased incomes and also asset accumulation by about 20 points, and incomes by about $140 annually per adult equivalent. Now, when you look at the livestock-related technologies, the key finding there is that they have positive and significant impacts on both food security and nutrition, and also in terms of asset accumulation, but the impacts on income were not significant. For the soil and water technologies, we find that their impacts are not significant, but probably this implies that their impacts could be captured through other indicators that may be related to soil health in terms of soil fertility and carbon sequestration. So in terms of going forward and also some of the reflections from this study, I think the key issues that are emerging is how can we effectively promote wider uptake of these technologies, including scaling and feeding into policy processes. But one of the things that I've really heard over the last 2 days is that we need to strengthen other support services, especially focusing on climate information, agro-advisories, and also looking at how we can improve the access to financial services and also linkages with the private sector. Also, there is need to strengthen the existing experimentation networks, and here I'm talking about youth groups, women groups, community-based organizations, in order to enable the communities collectively respond to climate change, provide opportunities for learning, and also build their social capital. And how do we also make sure that all our efforts really include the vulnerable populations, the women, and other marginalized groups in the society? Thank you.
That tangent debate is a hard act to follow. I'm still kind of reeling, but it has empowered me to perhaps be a little bit provocative in my presentation by starting out questioning or examining a little more closely how we're using this word transformation. I mean, it's the central word of this conference. It's a word that we're seeing everywhere, but it's being used to mean a lot of different things. In adaptation circles, it seems like it is being used to just mean bigger, better adaptation. So scaling up what we're already doing to adapt to climate change, which is very important. And I do not mean to minimize that. There is a lot of excellent work going on there, and we need as much of that as possible, as quickly as possible. But in the work that we've been doing, the research that we've been doing over the last couple of years on transformative adaptation, we've been looking at it from a perspective that might be a little bit more closely aligned with the way the IPCC defines it. So what I have here is first their definition from AR5 about what incremental adaptation change is. And they defined it as being more adaptation meant to preserve the existing system to make it more resilient to climate impacts. And they give examples of things like, adjustments to cropping systems with new varieties, changing planting times, using more efficient irrigation. So the kinds of things that a lot of us are working on here. But they contrast it with transformational adaptation. And they say that this is more when we recognize that entire systems of agriculture are going to need to change in pretty fundamental ways. I mean, they talk about, things like actually changing livelihoods, maybe pastoralists becoming crop farmers, maybe migration, really very dramatic changes. And this is not something that we see a whole lot of discussion about so far. We've done a lot of research to try to find examples of this, and there are not that many, but I think we're going to see more of them as climate change impacts intensify. So in our work, we tried to sort of unpack this term transformation, looking at it through the IPCC lens. We settled on kind of three main attributes that we would consider transformative. One of them is situations where crops are just, or varieties of livestock are just not going to be viable in the places they're currently grown. So relocation of crops and livestock varieties will be necessary. Also, fundamental shifts at a landscape scale. So thinking about situations where, maybe there will need to be a shift from crop agriculture to aquaculture as sea levels rise. The third one is significantly new application of technology. And an example that I can give there is in India, we're seeing more and more use of these low-cost poly houses that enable, they are an adaptation intervention in that they protect crops from severe rainfall and hailstorms and make water use more efficient. But they've also pretty significantly changed the production system for some farmers in that they can grow new things, they can access new markets that they didn't have access to before. So I want to pause for a minute and say that these kinds of changes that I'm talking about, these really significant changes, are disruptive and difficult. And we don't think that they should be the default. I mean, I'm an anthropologist by training, and I very much understand that what people grow, what they produce, is central to their identities. But I do think that in situations where the existing agricultural system may not continue to be viable, despite the advances that we're making, we need to start thinking about these kinds of changes a little bit more than we have been. So this is where farmer organizations come in. I mean, these are very significant changes, and they are not something that should be imposed from on high, by international organizations, donors, even national governments in some cases, because we're not going to need these kinds of changes everywhere. They are very local for the specific places that we're going to need these kinds of transformative changes. So I think farmers' organizations, existing organizations that are trusted, that already have a presence and an identity, are going to be some of the best messengers and the best facilitators for these kinds of changes. I mean, they can do things like provide technical support, improve access to finance and inputs, markets. So all of these pieces that farmers are going to need to make these really significant systemic changes. They can support systemic change through things like aggregation, processing, value addition, marketing, new market linkages, new equipment to process different kinds of crops or livestock that will be grown. I think they are going to have a very important role in this change. And I can see that I have 20 seconds left. If I had 5 more minutes, I would share some examples with you that might make this a little bit clearer, because I know it's a bit abstract. But, if I would be glad to continue this conversation with any of you after. Thank you.
So what I'm actually going to be talking to you about today is actually a revolution. It's a revolution in the way that we store, share, and use data for decisions. And we've named that revolution ERA, because we see this as really, and today and yesterday, and as Evan mentioned, as the launching and the start of a new era. We've heard for the past couple days that we need data. Next. And we need data to inform investments, develop new products, support policies, and build capacities. And what we've heard is that these data sort of revolve around 3 main topics. We need data on how practices affect performance, what works where, what works where, and the business case for those technologies. But if we think about where development partners can access those data, journal articles, document repositories, metadata repositories, and think about them in a very simple, just 2-way axis of usable and accessibility, I would contend that they all fall down in this quadrant. And that's exactly where you don't want to be, where the information and the evidence, whether or not it's because it's behind a paywall or takes specific knowledge, is either not usable and not accessible. So while as this community, we've done very well to increase the fairness, the findable, accessibility, interoperability, and reusability of our data. But from the development user's perspective, we haven't. So what ERA is trying to do is something fundamentally different. And that's for us to be up here, to make the data available and accessible to the masses. And so why are we thinking it's a new era? So we started with the conditions that we've largely heard. 36 of the 50 most vulnerable food systems are to climate change are in Africa. And we saw that we had, that should say, 30 plus years of agricultural research for development. And so we created ERA, a systematic review and meta-analysis to be able to utilize that information. We looked at 128 management practices and technologies, 78 indicators of productivity, resilience, and mitigation, 257 unique agricultural products. We looked at over 49,000 abstracts in Africa, 150,000 abstracts globally, and we retrieved data from almost 1,400 papers. We collated 75,000 plus data points. We layered on 11 additional data sets of soils, climate, and we're using this already with 6 different partners, and you can access it at this website here. And so what can you do with that? Well, you can answer the key questions that everybody seems to be asking. The first thing that was about the performance of practices. This is a screenshot from one of the websites, from one of the pages on the website. On the left-hand side, you can see there's 7 different apps where you can play with the data, filter the data, ask the questions that you have, not the questions that a scientist had and decided to do a meta-analysis on. A questions that you have on a specific product, on a specific place, under a specific condition. The bottom 3 apps there are still under development, but everything is open source and transparent so that you can see what we're developing with partners. And you can see that this shows you the climate smartness of these activities. Productivity, this is the percent change in productivity, resilience, and mitigation. We're also developing tools to find out what works where. So Christine Lamana in our group is leading, linking that performance information to the available spatial data, using machine learning and ecological niche modeling to look at the suitability of practices in different locations. So to be able to predict in areas where there are no data, in those data deserts. Andreea is leading the charge on finding out the business case. The constant reframe here is the investors have no information about costs, returns of these individual practices. Well, you can see that this isn't true. There's a poster outside so you can follow up and see the real colors, that we have over 2,400 observations on economic data in Africa. We may not have the most current information for that specific location, but we have an idea if we're heading the right direction with some of these technologies. And through collaborations with the FAO and IFAD and Aslihan Arslan's group, we've collated a lot of the microeconomic data about the barriers to adoption. We looked at 168 additional papers on 90 technologies so that we can figure out what are the likelihoods of positive associations of socioeconomic variables. What is the likelihood of adoption? And these are also, you can check out a poster outside. And so what I think is that ERA underlies all of these current decisions, and we're already using it with a number of partners in that way. But that's not the end of ERA. This is the start of a new era. And we need users that want to develop new case studies, new ways of using the data, new apps. We need development partners who think that this shouldn't be restricted to Africa, that thinks that this can be utilized in South Asia or Southeast Asia, and want to work with us to expand the database in new ways, to new languages. And we need scientists to think about how to use this information. All of it will be open source. You'll be able to access it with an API, and how we can work together to really make development data more usable in the future.